the Mountain Laboratory was established to provide a permanent site for the Dayton Project activities that included operations as a nuclear weapons research facility during the Cold War. The lab produced detonators, cable assemblies, timers, firing sets, and other equipment. In 1954, the Mountain began working with the radioactive element tritium, the rarest isotope of hydrogen. Tritium boosts the power of a nuclear weapon by greatly increasing the energy of its explosion. The scientists and technicians at the lab worked with tritium in a variety of ways until the mid-1990s. Mound Lab scientists also brought innovation to the U.S. space program by inventing plutonium-238 powered thermoelectric heat sources called SNAP, or Systems for Nuclear Auxiliary Power, which added in the unmanned exploration of space focused on probe missions to the outer edges of the world. This next keynote will focus on changing configuration management and the new digital world.
Thank you, Yvonne. Thank you for the time. I'm BJ Mayhew, and I'm super excited to be here, and I'm actually super excited to have the opportunity to introduce my friend Chris Garrett. But before I do introduce Chris Garrett, I've got to talk a little bit about Dell. I'm hoping that you're all familiar with the brand of Dell, right? I'm also hoping maybe you've read the story of how Michael started Dell 38 years ago in the dormitory of his college at the University of Texas, right? But what you might not be aware of is about 5 years ago or so, we merged with a company called EMC, and we created this new digital entity called Dell Technologies, right? And at Dell Technologies now, we are a company of probably around $94 billion in revenue and 160,000 employees right now at Dell. And I would say that we are probably the largest IT infrastructure company in the world today. We cover everything from storage, from compute, to networking, to data protection, to virtualization, to the application delivery process. Not just the applications in a sense, we also partner with our friends from VMware and help us deliver applications which delight end users. But primarily, we at Dell are focused on following the data, whether that data ends up in an on-prem data center, a private data center, or a public cloud. That's what we do at Dell today. So Chris, before I introduce you, I've got a solid, well, not quite a resume here, but it's very nice. So I'm going to introduce to you today Chris Garrett. He is a senior level executive, and he is the technical advisor for the Systems Engineering Air Force Lifecycle Management Center at Wright-Patterson Air Force Base. Today, he serves as the recognized Air Force authority for systems engineering and for weapons systems lifecycle management, and he's charged with providing technical oversight and advice to high-level Air Force management officials. And in this role, Mr. Garrett is the lead engineer developing the Air Force Material Command strategy for digital transformation. He's spent 27 years of active duty service in the Air Force. He's been working in the areas of electronic warfare, test, space, aircraft sustainment, and he's held the role of Deputy Director for Engineering and Technical Management for the Air Force Material Command, where Chris is focused on 3 key areas: systems of systems analysis, open systems architecture, and strategic planning. I've known Chris for probably 5 or 6 years, and my best story of Chris is I think it was last year he called me in this event. They may have been the initials PH, or what were they, HP? I forget. But anyhow, we've been friends for a long time, and I've enjoyed his time. And Chris, the podium's yours, so thank you.
That's a great one. That's great. That story definitely never gets old. So we're at WITS conference, right? So we're talking about IT, and I was thinking, how many people deal here, like you would say, regularly with software development? So I'm just getting a feel here, right? So, okay, all right, cool. Right, so I could have titled this, I think, configuration management and change management, because I think they both, go together in my mind. How many of here, so I'm looking, I'm a double E, right? I wrote some software in my day, Fortran and some Ada back in the day, but I'm not a software person by any stretch at all. So, my friends that I talk with who either in the Air Force or own businesses like Mike, and they start telling me about, GitHub and GitLab and Jira and its combination with Bitbucket, right? All to try to manage software development, both at a process level and also technically speaking, right? As you fork out, branch out, bring it all back together, do software better in an agile way, whole idea of DevSecOps. So I assume, again, all those software people, right, and maybe more, right, we're all familiar with those kind of tools that I mentioned and how you as companies or organizations are doing your software management. Is that true? Just hands raised again so I can kind of see. All right, so as a part of that, right, the software people have been doing this for a long time, and both a lot of bad, I want to say, right? When you go back, 30 plus years, and I think the software people helped us all as a community learn that, you can be something like CMMI 5 and really develop bad code. So it's, back in the day, right? Back in the day, hey, we're level 5 and you're delivering really bad code. So it was way more than just following those kind of processes. And I think that even so, the lessons, the very, Wild West nature of software, in my humble opinion, and how the software people, I think, have really addressed that to get a lot more control and be a lot more systematic, versus like, the hardcore, engineering skills, like, again, double E or Mac or Arrow. I think that's actually, to me, it's ironic, because I think that in regards to system development, we've learned a ton from the software people. So for example, like who in here has used or is very familiar with UML, Unified Modeling Language? Okay, so, as a software developer, right, you don't have to, use UML, but the case that I want to make today, and I, again, it depends on your software application, right? But the case I want to make, when you think about the complex system, so the context of my discussion, what I've been focusing on for the past 2.5 years is I've really kind of looked out in the future, and particularly I think it's good for us here, and I certainly look forward to your questions, to really think 10 plus years out. I really think we need to think 10 plus years out, and I'll try to prove that, or at least substantiate that in some manner, both as we look historically at what has happened, and you yourselves, hopefully with your questions, can think through that too. But it's a long journey of this change in the way we do business from the way we do it today. And the context is air vehicles. So as you're thinking, so in my discussion, right, I'm thinking of big rocks in the Air Force, big air vehicles, B-21, F-15, F-16, B-52, and you can think UAVs right now, but in particular, for sure you should, in particular, is right, the whole UAV thing for the Air Force is to me kind of weird, and I don't get to keep up with this daily, right? I get little pieces, now and then, right? I'm trying to figure out what is the Air Force doing with UAVs. So, but clearly in the Air Force pot right now, just for context, right? B-52s here, another 30 years at least, maybe 50, another 30 years at least, right? In the Air Force plan. F-16 post block, near that time frame. I don't know, it's like 2048, somewhere around the late 40s. F-15EX, right? You could think 30 years. F-22 is back in the mix somehow, some way. I don't know exactly the date that the Air Force has put on it. Obviously, B-21, kind of weird, kind of in the middle, in my opinion, right? F-35, and then future platforms that the Air Force talks about a little bit, like NGAD. So that's the context of my discussion today when I talk about change management and configuration management of very complex systems which are a combination of hardware and software. So I usually, I get the privilege, right, to give a lot of speeches to a lot of groups, both big and small, and usually inside the Air Force, like with, captains, majors, lieutenant colonels, 13s, whoever, in big or small groups, I'll spend probably 10 minutes bringing up slides and facts of what China's doing today, flat out. Discuss why it is really, and if you've been to, let's see, what is AFA is next week? Yeah, so if you've been to AFA, it's next week, and I would just challenge whoever's going to go, if any of you are going to go, you're going to pay attention to how many times they say China, right? And you're going to pay attention to how many times they say the word digital. Because if the last 4 AFAs are any indication, they're going to say those 2 words a lot. And if you've read anything, one of my heroes lately is a guy named Major General Cameron Holt. Anybody know General Cameron Holt, right? AQC, amazing guy. Just Google him, and I think he retired like in June, and he did some speech out in LA or San Diego that I read, amazing speech. And he just talks about this, about China, which is like, I don't think people really understand where they are. I mean, some people do, but I don't think as a nation we do, because we would be making different decisions. If we did, in particular, we'd be making different decisions in regards to the speed and the investments that we're making to get to that speed of weapons system change and development. Bless you. So, so that's the context of, with those remarks, is anything that I said unclear, or anybody have a comment right off the bat on what I said? Because I like to get off on the right foot. Any comments at all? Okay, so, all right, here we go. So what we want to do, what we're trying to do in my group, which I'm in the home office in LCMC EN. I work right there in ENEZ as a senior leader. We all do. And what we're trying to do in our group is figure out how, so here's like a vision. Perfect configuration management all the time that lends itself to rapid change, perfect change management, which leads, of course, to rapid modernization, rapid change that is highly assured, both in regards to safety, security, and gives you the capability that you need, the optimal capability that you need, not exactly what you think you want, but more or less what you need, which implies a robust trade space. So, but the idea with all that, because it all does fit together, is to really go fast. And as we ask ourselves, like, do we need to go fast? Yes. Are we going fast today? Not really. I mean, not as an enterprise. And so what are those things that we need to do to really help us do the vision, right? Perfect configuration management that lends itself to all those things that I said. And again, why I started off with the software discussions is because the area that we're going to, let's see, I'll go to the next slide. Okay, so I talked a lot last year about this slide, and I'm not going to talk about it this year, but I wanted to use it for a reference because this is part of the larger vision that we're marching to move, and this sets up the rest of the briefing, right, to base our decisions and our development on models, and in particular, that is architectural models, SysML, and that leads back to the whole discussion that I started with is SysML is built on UML. And really what we're going to propose, I'm going to talk about in this briefing, is a way of thinking in regards to SysML for us all in the acquisition process, us all in the government working with the contractors. So the blue arrows at the top, right, that's the movement of models and data from beginning to end so that we can collaborate well. And I was going to, I wonder if I can still do this. I pulled this, as I said, there was a bunch of tools that the the software people have brought about, and I was reading one of them lately, and I thought it was perfect for framing what we're trying to do. I wonder if I can. Okay, so no advertisement here. I just could have pulled up a bunch of different tools. I pulled up GitLab, right? But as you want to replace GitLab with, generic tool, it says, GitLab is a DevOps platform that empowers organizations to maximize the overall return on software development. So in this case, I would say, right, I'm thinking about taking what GitLab does as a DevSecOps and applying it to not software, but applying it to the whole system so that the overall return on system development by delivering capability fast, they say software, but I'm going to go ahead and change the words here. Delivering capability faster and efficiently while strengthening security and compliance with GitLab or whatever tool you end up with. Every team in your organization can collaboratively plan, build, secure, and deploy, says software, but capability to drive business outcomes, capability outcomes faster with complete transparency, right, for everybody, consistency, and traceability. So, right, that's why I started off with what I started off was like, look, hey, we can learn a ton from the software community, in my opinion. This is WITS, right? And so we want to, and we are. And so as we move, the next chart, as we move to what I'm pushing and my leadership's pushing, and maybe what you've seen in the other services even, NASA is hosting at the end of next month a large MBSC conference, I think it's government only, where we're all going to meet, Army, Navy, Air Force, NASA, in Langley, NASA, on the East Coast. We're going to talk about this is all that we're doing with MBSC and try to figure out, hey, what are lessons learned and what can we do in common? So I am pushing, as the tech lead here, for a change of culture, which I think is your next group, right? Your next group is a culture group. And so right now, for example, in my home office in LCMC, in the home office, where I think it's like 300 people, I think, in my home office in LCMC EZ, I think I have one SysML expert. Like I would put this guy, Keith Siders, up against anybody in the country, right? Like this guy's a true expert. One. And as I've interfaced with the different program offices out there, we just don't have SysML experts in the Air Force. I mean, like none. No, that's not true. We have a few, but I'm exaggerating. Right? We don't have them. If you look at percentage-wise of our workforce, right? We have like LCMC's got like 4,200 engineers. We got a handful at best. So we have a massive culture change ahead of us. That's why I'm saying, hey, think 10 years. But as we look to go fast, and we've said, okay, we're moving to this digital world. What does that mean? That means we're going to start using models. In particular, government doesn't design or manufacture. We're going to use architectural SysML models to embody, to depict, to do a functional decomposition, right? To contain our weapon systems, not necessarily just one model, right? It could be a bunch of integrated SysML models, but that's what we're going to do. And we're going to represent that complexity of a F-22, a B-52, whatever those air vehicles are. We're going to represent that complexity in SysML, which you can do. And by modeling that and establishing the interaction of a model with the analysis that the government wants to do, whether it's cyber analysis or safety, analysis with airworthiness, or operational analysis, right? How does it work in a mission, like a tool like AFSIM, or so forth and so on, integrated with high fidelity tools. That's what I'm talking about. And in particular, if you imagine a future world, so that maybe that's 20 years, but imagine a future world where every one of my weapon systems, as I already said, all those planes that I listed, going to be here. I didn't list the B-1, right? Or the A-10, I don't know if they have longevity. But if you look at what the Air Force has said, roughly is 2050 with those platforms, and you think, okay, in 15 years, 37, if I have the Air Force completely modeled architecturally, right? So in SysML, and whatever version SysML is, right? 3.0, 4.0, it's going to go right from more graphical to more text-based, and 2.0, that'll be helpful for a lot of small companies. That's going to be very helpful, the where SysML is going. And so I imagine in the future, right, as you look at companies that are pushing out these software tools like Jira, like Bitbucket, like GitLab, like GitHub, and plenty of others, right, that I could have listed. Smaller companies, not as big as those products, but smaller companies all over the place that have software management, configuration management, change management tools. That's the future that I envision, right, with SysML 3.0, 4.0, is because I believe this is the absolute way that we, quote, do modernization and get our systems through the acquisition process. And again, particularly what I'm thinking about is modernization on all those platforms, except for NGAD, right, which is in development in some means. All those platforms are real. You've seen pictures of the B-21. I mean, all these platforms are very real. And so we're looking at a future of how do we modernize those weapon systems really, really fast, like do a radar upgrade in less than 2 years, right? Which typically today, if you look at a platform, right, you're looking at roughly 6 years. How do we get architectures that we can make the change? I mean, like I want to change a software algorithm on a synthetic aperture radar, and I do it in Jira or whatever, Bitbucket, and then that automatically goes to a SysML model, makes a change, flies it out in an operational mission and asks them, and shows me within minutes of the effect of that change. By the way, that's happening today. If you track the Sentinel program, used to be called GBSD, right, out with Northrop and their team, right? They're connecting Jira using eCube to Cameo, to mission models, to SDK, to a whole bunch of tools, and it's very cool. So you can make a change in your software algorithm, and the team, the collaborative team, can see within minutes, this is the effect of the change. So that's where we're going. Is that at the enterprise today? Not even close. I mean, it's not even close. And I think everybody knows that Sentinel is a very well-funded program, which it absolutely should be. But as we look at programs across the Air Force, right, we have a long way to go. That's fine, right? Big vision, start small, scale fast. And that's what we're trying to figure out today, which is how do we scale? How do we scale all this? And so this is a thought process. As we've dug into this so it's been 2 years right now. Keith Siders, right at 2 years, he started this about October of 20. And he and I particularly have been working, we've done a lot of interaction with NavAir, we've done a lot of interaction with the Army and MITRE and aerospace and I don't know who else. I know we've talked to them. So in laying out a structure that you can use as the basis of a SysML model being the mechanism by which you're going to do change management and configuration management, there's a lot of things. I mean, this chart was just put together probably a month ago. And that was after almost 2 years of us just trying all kinds of things to figure out, so we go down a path, right? 2 years ago started, went down a path. And we realized, holy smoke, if we're really going to use SysML and these MBSE models as the basis for all our decision making, the basis for how we interact with the contractors, the basis for how we do our analysis, security, assurance, cyber, operations, costing, right? If we're going to really do that, then one thing led to the other, and this is our current thinking. So our current thinking is, you can see at the bottom, so you can see at the bottom, we have libraries. I'm going to talk more about these reference model libraries, government reference architecture, and certification architectures for, right, stuff like airworthiness and cyber. All that leading to what we found out, and you can probably guess, as we've looked and talked to lots of groups, it's like, look, for air vehicles, which today you all probably know, right? Every air vehicle isn't a stovepipe, right? F-16 does not do things like F-15, doesn't do things like B-1, like B-52, like B-2, like B-21, right? None of our programs, right? It's like you were on your own, right? I mean, you have to follow 516 airworthiness, but how you do everything, I mean, you're on your own, completely. So as we looked at this, we said, all right, hey, and that's fine with paper, right? That actually, it works. I mean, there's improvements, right? But it works with paper because you're dealing with your contractor, you're briefing your chain, so paper works. It's really not the way you want to go in a model-based digital world. You don't want to have 20 different ways of doing business. You want to have a unified way. For example, I don't know, is Sean Lyman in here? Yeah, there's Sean. So did we talk in this forum about like log IT at all today? Well, so for example, log IT, the log reference architecture, right? The new way that our sustainment basis, Tinker Robbins Hill, working with LCMC programs, right? That's the way we are going to sustain our weapons systems in the future. So, right, we're working on MROI, working on PLM, working on Blade, working on flights, and working on Escape. Did I get them all? Right, so this whole repertoire of tools that the log community under A4, working with Sustainment Center, are putting together to help us be agile, fast, and efficient in the future with moving all this data around. And obviously we got to get linked with DLA, so the whole system has to change. And that's where we're headed with them. So what I don't want to happen is as we move to back, let's see, as I move to a MBSE-based acquisition system, I don't want every single program I don't want every single program to figure out how they do their MBSE and then relate that to the log IT architecture. I don't want that. That seems very wasteful. And so another good reason of many, right, that I want to establish a way of doing business. And so as we thought about that, okay, well, helicopters are different than planes, and bombers are different than fighters, and fighters are different than cargo, and cargo are different than UAVs. Very true. So as we thought through this, we said, hey, the PEOs, which really are a domain, right, right, they'll function, fighters, helicopters. We believe that they will take their architecture based upon a reference architecture, which I might talk a little bit more about, right? And they're going to add more specificity to it. And then the SPO for like the F-15 NWA will add more specificity to it. And then finally, and they'll put that out on a CDD. Finally, you'll have the prime contractor, which drills all the way down, gives you a very specific system model. This is all MBSE, right? And then the top two areas that you see on this chart are really still conceptual as we're thinking through, okay, well, so we have the final system model, and just like I showed on this chart, at the bottom you can see system model in the center, and then PLM at the 4 or 5 o'clock position. That's the same thing here. Once you get that system model working with your contractor for initial contractor support, CLS support, right, you're going to make sure that your system model relates perfect to the final production model, which is really going to be related strongly to PLM, all that data and that data management, and particularly as all that data management now relates to the log IT architecture. And then finally, you're going to have the operator out there doing his thing every single day, making his changes to each, as we say, tail number. You notice I haven't used a couple of words, and I'm not going to use them. So every level of the architecture is maintained baseline, just like the software people do, right? And you go from, as I showed, all right, let's go back. Okay, yeah, so on this chart, right, it goes from the very specific concrete all the way to the abstract. And again, that's pretty much what the software people do. So a couple of considerations, a little busy chart, right? Software attempts to merge into a single trunk. So you have what we're calling a reference architecture. And we spend, we have another brief, right, that we'll spend, a good hour, and I apologize, I don't have the time today talking about what an air vehicle reference architecture is. I just came from a meeting with the F-35. They're doing a fantastic job with Lockheed building a system model of the F-35. Obviously, very specific, looks like the F-35. I think they're doing it in Rhapsody. And we're building, and we have already built, a reference architecture for air vehicles. We sent this out on the web, if any of you saw it, back in June. 13 companies responded. Great response. Appreciate it if you responded to our RFI on our reference architecture. And we're going to brief this at NDIA, first week of November. We're going to brief our reference architecture. And then we look to set up a series of workshops next year, working through with industry on what that reference architecture should really be. And again, I apologize, I don't have time to go through that. But the idea is we know that this is a consortium industry-wide approach that we have to get in sync if we want this to be successful down at that bottom level, particularly that domain reference architecture. We have to get that right, and that has to be an industry consortium joint effort. All right, it's 3:01. So, you have the slides. They're going to put them out on the web. I'm happy to take more questions. There are gobs and gobs of details that I could go through, particularly on this reference architecture and how we see going into specificity up the ladder, so to speak, here to get to a final system model. But we are basing this, as you can see on the right, we're basing this on the Joint Services Specification Guides. They've been out for many years, and even before they were JSSGs, they were out there as MIL standards. All that, if you're not familiar with them, all those have been consolidated, and they're really excellent guides for you. So let me see. I want to get to your questions. Hopefully you get the gist of what I was talking about as I talked about going up the ladder there from abstract to concrete. Very similar to what the software people do. This is our approach. As you can see right there, the classic functional to allocated to product baseline. Nothing changes there. It's just all in a model now. All right. So configuration management, configuration change of MBSC SysML models is really equivalent to software configuration management and change management. And it's even going to be better with SysML 2.0. We absolutely know that multiple levels of the hierarchy are needed. Each level has its own repository, and we really need to work through the process, just like the software people have done, with their tools to really nail down how we're going to do our model management. So with that, happy to answer.
Great. So we do have some questions for you. Excellent. First one, PEO Digital and SAF CAO are building similar solutions for mapping out architectures and standards and creating repositories. Is this similar to those?
So PEO Digital under Mr. Word and who?
SAF AQ, Chief Architecture Officer, CAO.
The Chow, okay, they're doing what again?
Building similar solutions for mapping out architectures and standards and creating repositories.
Yeah, so I'm not super familiar with what they're doing. We do work with the Chow office bigger, but and I'll take an action to follow up with them, Sean. But I'm very convinced that no one so this is conceptual, right? What I talked about here was conceptual. If there are tools under Mr. Word or the Chow office, then I'm happy to use them. I wasn't prescribing tools here, right? I was prescribing a methodology of what we are pursuing. We frankly have not even gone out and looked for tools yet, because like I said, that diagram's like a month old. In fact, we just changed it last week. We haven't looked for tools yet. There are tools out there, and I appreciate the heads up. Whoever submitted it, I will talk to Mr. Wirt, his office, and the Chow office to see if their tool and their level of detail suits this. I'd be happy to use their tool.
Great. Next question. How are you going to avoid reference architecture driving design, much like airworthiness standards drive tube and wing design today?
Yeah, so the reference architecture, in one way, will drive design, right? Because it will be a very abstract basis. But for example, the Air Force, in doing this, and Army and Navy are doing this too, with like Future Vertical Lift or their Optionally Manned Fighting Vehicle or MQ-25, right? We're all moving to use standards, open standards, particularly for the Air Force. That's as far as the bus goes on an air vehicle, right? That's OMS UCI. That's what we're doing. That's obviously an issue when you look at the legacy architectures like F-16. I know F-15EX, right, is really trying to do that. Like right now, they're trying to do that. And so the reference architecture, when we finally get those open standards in there and we lay it out at the right WBS level, whatever that is, 3, 4, 5, I don't know. The way to do that we've shown is through a consortium. And so that's why I've already contacted Lockheed, Boeing, Northrop, for example. I've talked to them. They actually have got our reference architecture. They've made comments on it, positive comments. So we sent that to them. We sat down with them as well as other big companies and said, hey, this is our architecture. This is our thinking. What do you guys think? And they're like, yeah, I think you're on the right path. So we have a follow-up meeting. Is anybody going to GPDIS? It's out at Phoenix at the end of September, GPDIS, interoperable. So I'll be there with Lockheed, Boeing, Northrop, and we're going to sit down. They've already seen our architecture, our thinking, and so we're going to lay out a plan of action, the intent at the end of September, and then, like I said, we're going to brief it in NDIA. But the idea is to get with the people, particularly, right, who are your primes, Lockheed, Boeing, Northrop, and General Atomics, you know, and just like we've done, just like the FACE community did, SOSA did, Victory did, OMS UCI did. I mean, any effort where it's going to reach across your enterprise better be a consortium, right? And so that's our intent with this air vehicle reference architecture. Get with the primes, already done that, got them by name, we're meeting, and we're going to work through this. And look, think 20 years, right? This is a long journey to get somewhere, and are there going to be lots of issues with all these platforms, 15, 16, so forth? Yeah, there are going to be lots of issues, but I mean, that's like, well, then what's the alternative? I mean, we don't do anything. We just let them keep on their own. I think that's a bad future and a bad strategy.
Agreed. No, I think that's absolutely the right approach, is bringing in the consortium. Speaking of consortiums, are we working with the other services, Navy and Army, as well as the Air Force together on some of these reference architectures?
Yeah, so that's a great question. So we're getting there. Part of the deal is like if I could have this reference architecture, for example, that we have sent out, and you can still get it if you're interested. It's in, this architecture is in Sparks, Enterprise Architect Sparks, but which, anyway, lots of issues with the particular version of that we used and running on Windows, but you can navigate through that. It's just a little painful. Nevertheless, right, we can provide that to anyone. And so all the services from what I've worked with, you know, I think it's Adrian Day at Army Air, had conversations with her, worked with Matt Sipes, worked with Christy Yorko at Nav Air. I mean, we're all getting there. I mean, this is emerging, right? So just as I was meeting with the F-35 today, showing them our architecture, they're talking about their architecture and how, where we're headed, for example, was particularly with airworthiness and how we're going to use SysML to help us in the airworthiness process. It's like, okay, I know what you guys have been doing, you know, great work. The issue is we're all really just kind of starting. And so we are exchanging information. Like I said, NASA's going to host this NBSE forum into next month. But as we were talking to them, they're like, okay, so like, what have you done with your architecture? And I was like, nothing. I mean, so it's like, we just put it together. I had one guy working it, and this is where we're at today. And then we took JSSG 2009 for electrical systems, and we drilled all the way down. We can give you that model too, to show, okay, for this framework for acquisition of an air vehicle, this is how, for example, you would do an electrical system. And so we just finished that, right? So it's like, I think where we're at with all the other services is in principle, we agree that in the digital world, a reference architecture seems very suitable. Have we figured out all the ins and outs of it? No. And for air vehicles, it's really, really hard because when you hear groups like Sentinel, which is a great example. Well, I mean, Sentinel is one of a kind. I mean, right? They can make decisions and they can just do it because that's it. It's Sentinel. But for us, right, we have all these platforms. It's very, very tough, right? But the idea is we are convinced that we need to go down this path, and we're continuing to think, you know, I think 20 years ahead. It's like, get on this path, and we'll get there in 20 years because all these platforms are spending gobs and gobs of money today for capability, which they need, which the country needs. But eventually, right now, I can tell you today, having worked with them all over, 10 years now, I mean, they're slow. They're slow, very slow, and very expensive. And so the way we're doing business today in our air vehicle weapon systems cannot be even close to the way we do business in 15 years. And the sooner we can get there, the better. And so the Air Force, I think, will gain momentum, as well as the other services, I think, will gain momentum. And as we hopefully like I said, we have this meeting next month where we're going to open up a dialogue with the Army, Navy, NASA, and that's just going to grow, right? That coordination is just going to grow.
Yeah, there's one thing you're not aware of. I've been working with Jamie Suter, and you know Jamie. She's been working with the Navy on logistics product data, and they're doing system L modeling for logistics product data. Right. So they sent it to us to share with Keith to take a look at, just to see something across services, because we all use the same standards. So we are trying to link up there and get some synergy as there too. But actually, that takes us to the close of the time. So, Mr. Garrett, thank you very much. We greatly appreciate you sharing this with us.
Thanks, Sean.
And thanks for helping out Althea. And it is break time now. Thanks, man.